Hi everyone, I'm Nalin Aggarwal from American Express, and in next few minutes I'm going to give you glimpses of how we are taking very profitable real-time decisions on more than $1 trillion worth of transactions and more than like millions of applications for credit card that we receive each year. Data attribute anomaly detection system is one such system which is used across fraud detection, line assignment, credit underwriting, and customer management, and helps us to identify attributes, features, or variables that are abnormal, that are not really very known. So let me start with the motivations behind this system. So the first motivation is that we had a lot of data in American Express. So we know what is the standard across various processes. Then we needed a system which could allow us to do a quick identification of very obvious anomalies, and that too without much of human intervention. That is, the system should be very, very objective. And last but not the least, it should facilitate a very prompt corrective action. And talking about anomalies, here are like few sources of anomalies, and some of which are very, very obvious, like incorrect data entry, very obvious source of anomaly. There are sources which are not so obvious, that are if there is a change in the distribution or the means of a variable. So for example, if you see that usually you see an income of 100,000 for the incoming applicants, and that suddenly rises up to 150K, then you will say that, okay, have I made any error while filtering out my data, or is there any issue in my data collection procedure? Okay. Now, with a very strong motivation and some obvious and unobvious sources of error, let me walk you through the process of the system. So we have standard data and the tested data, which goes as an input into the system. And let's take an example of a tested data, let's say a credit underwriting data, which is to be used for modeling, containing variables like consumer bureau score, utilization, income, and let's say 100 such variables. So when we give these two data sets into the system, in the first pass, what system does is it compares variables in tested data with the standard data and comes up with issues like formatting errors or unexpected values. So for example, if in our data we see a highest value of 400% for utilization, we know that, okay, there is something wrong with the data. Or in terms of univariate mean distributions, if we see that the consumer bureau score has suddenly increased by 50%, then we can say that, okay, there is an inherent data selection bias that might have happened and which might render my data unfit for modeling. Once I am done with the overall variable by variable comparisons, I go to overall data comparisons. And the key thing here to note is that the system is able to score the data on a scale of 0 to 100, where 100 would mean that my data is absolutely good to go for modeling. There are looks very similar to the standard data, while a score of, let's say, 30 would tell me that, okay, data needs some deep dive and I need to really find out and fix the anomalies in the data. And actually the system also tells you that, okay, which are the specific attributes that you should look for in order to fix the data. Now, as far as the brain behind the whole system goes, we have leveraged some very traditional techniques like Cohen's d method to basically compare variable by variable distribution and the missing percentages, while we have also leveraged for overall data comparisons very, very basic machine learning classifiers. The way it works is that we take our data, we label the standard data with a value of 1 and the tested data with a value of 0. And we try to develop a classifier which could successfully distinguish between these two data sets. Now, if we are able to do that, then we will say that my tested data is very, very different from my standard data. And the system also publishes the key reasons as to why my tested data is very, very different. Then I have a flavor of visualization in the system as well. Basically, we have leveraged stochastic neighbor embedding technique to compress my n-dimensional data into a two-dimensional form so that we can identify some obvious clusters which might not be very, very obvious if we just analyze the data otherwise. So we have leveraged some very traditional tools like Python, scikit-learn, Spark, and Hadoop. And the reason we have kept the system very, very simple is because we wanted it to execute on 100 million plus rows and maybe like thousands of variables. So the system is very simple and effective. In the end, I would like to thank everybody and basically end my talk by saying that at American Express, both science and sense are going together and enabling us to provide best customer experience with a healthy profit and revenue growth. Thank you.